Hello again, everyone. We're ready to get started with our webinar on our 3D product strategy. Today's agenda for the meeting is going to start off. We'll go through the housekeeping rules. I'll give you, for those of you who aren't familiar with the company, a company profile, an introduction to the content, what we'll be covering, and then we'll go into the body of the webinar, which is going to be some background information on 3D CAD and technical, and as it relates to technical illustrations. And then we'll actually do a new, a live demo of our new product. And then we'll wrap up that with sharing with you some of our strategy, 3D product strategy for the future. And then we'll wrap up with some of our a summary and a Q&A session. So the housekeeping rules again are, if you experience any problems when joining, use the questions function to communicate with us if there's anything that problems that occur while we're going. All attendees are muted for the duration of the webinar. Computer audio is the recommended option. And there's also some associated materials that's over in the handout sections. We invite you to, there's some material there, PDFs that are related to today's webinar. So we invite you to drag and drop those to your desktop. You can post your questions at any time during the webinar using the questions panel. So feel free to just post your questions as you think of them. And then, of course, as always, we'll wait to the end of the webinar for a Q&A session. Background on Larson Software Technology. We're based in Houston, Texas. We recently moved, but we've been in Houston, Texas, and since we were founded in 1984 as graphics technology experts for 30 years. We develop powerful, innovative graphics software and toolkits based on open standards. We've always promoted the CGM usage with a free and CGM viewer, which we've now turned into a subscription based product, which you can get on our store. We're also the developer of the first HTML5 viewer that eliminated the need for plugins. We're a member of the CGM Open Foundation. Larson's products simplify the graphics workflow for technical publication professionals. So with that said, now I'm going to turn it over to David Manick for the body of our webinar, and then I will be joining you at the end for a Q&A at the end of the webinar. So take it away, Dave.
Thank you, Don, and good morning, good afternoon, good evening to everybody. Thanks for joining us today. I think we've got some really good content for you. We've got a new product which we're going to preview today. First real live demo we've done since the development. So we're really looking forward to that and some of your feedback, hopefully post webinar. So as a way of introduction, we're really known as a 2D graphics company because of obviously the name of CGM and our association with it. But 3D keeps cropping up with people's requirements and both delivery and consumption. So we felt we'd take that on board and begin to develop our own strategy around 3D. Because really 3D enables creation of data through engineering and design, through to delivery of visual information, through various viewers and so forth. So we understand CAD is very capable of processing data and exporting into applicable technical illustration file formats. However, we also understand that technical illustration has some very specific requirements not usually present in CAD systems. So we strive to make the manipulation of the model fast and intuitive. In other words, a really easy piece of software to use. And you'll see that later on. Also, the export of data is, again, the CAD systems are capable, but can they give you the right quality of optimization, and can they finish the illustration off? So in today's webinar, we want to give you some background information of where our thoughts are and why we're developing what we're developing. And also perhaps discuss a bit about the future, where we're going, the next phase of development that we're going to take on board. So the objectives today are give you that background information, what our beliefs are on 3D data, where it's used, how it's useful, demonstrate our new conversion solution, describe really how the new software solution could integrate easily into your own workflow, and at the end present our own Larson's 3D product roadmap, really, where we're going in the future with respect to 3D. And also we'll give you an opportunity to ask questions. Please do. We usually get to them at the end, not during the webinar. And if we can't answer anything post-webinar, during the webinar, we'll get back to you post today's event. So some background information. We know a lot about 2D. One of the pioneers of CGM. And one of the overriding drivers really of publications and illustration is always cost. You want to get those costs down. We're always seen as an overhead. Technical publications are anyway. I don't really see it that way because they can really help support equipment which can drive costs down as well. So we still see 2D illustrations dominating, and that's really because there's a lot of 2D legacy data out there. So 2D is still probably going to be the primary format to deliver technical illustrations, technical graphics. And it's got a support of some good file formats, robust, trusted, CGM, SVG, PDF. So there's a good base to work from there with file formats. The use of 3D, however, is much more complex. And that's probably because where it originates from, which usually is engineering and design. There's a lot of systems out there. There's a lot of way of getting data in and out, a lot of way of creating data within those systems as well. And with that, there's also a greater access to that 3D data because there's more being created. So the first question is, do we convert that data to 2D with obviously hidden line removal and so forth to create a kind of a traditional 2D illustration, and that is still happening. But also, perhaps in the future, we'll see more the display of 3D information, which again is already happening, but probably not in the volume that we might have expected at this time. And there's a lot of reasons for that. There's cost and so forth that drives these things. You might need business cases to deliver 3D information, viewers, and so forth. So a lot of things to bear in mind. Also, there's a lot of 3D formats, both proprietary and open. So how do you choose which one's right, which gives you the best quality, and so forth? So in other words, what 3D formats gives us the best results? This is my opinion, so obviously people out there might disagree with me, but I still think we're in a 2D creation and delivery paradigm. There's a huge archive of 2D illustrations, and it's very unlikely that the legacy 2D illustrations will be converted to 3D and actually deployed. I think that's very unlikely. So these illustrations are going to be around a long time. And obviously 3D CAD data can be converted to 2D using various methods, including the CAD system itself. So 3D graphics are, at the moment, I see them predominantly being used in spare part catalog environments. And there's a definite benefit to that. but the cost could be greater than just creating 2D. But also the delivery and the display of that data, it could be more problematic. Has the computer got the right software on? Is it capable of doing it? Is it kind of proprietary? So there's lots of questions to ask there. And one of the things that really surprised me is that in the aerospace and defense industries, that S1000D has never really specified an open 3D file format, which really gives it's open season really to use anything that you can lay your hands on, which does not seem to kind of fit with a standard that we're trying to look for in these open formats, XML, CGM. And I think in aerospace and defense, 2D still dominates, mainly for delivery, which is CGM, which becomes part of the project, or SVG for display. So what does the future look like? I think it'll still be predominantly 2D, but it'll be more of a combination of the two where it fits. With 3D, there's definitely benefits, but there's also a lot of dependencies and pitfalls that you could fall into. And the cost could be greater to deliver it as well, which is always a factor within publications. There's definitely benefits to 3D, like visually it's easier to identify parts, view from any angle, animate parts in 3D for removal, repair, maintenance procedures. And you can easily reuse 3D CAD as well. So you could update the model and possibly update the illustration, the end product that you're going to deliver quicker and easier. So obviously the dependencies are, does it exist, the 3D data? Is it accessible? Is it secret, or is it something that's proprietary or IP around it? Because that data is more valuable perhaps than the 2D for somebody else to take an idea or whatever. And is the software available to easily repurpose that CAD data? In other words, turn it into a 3D spare parts catalog or a procedure. So considerations, 3D. Certainly if we're converting from 3D to 2D, we want the best possible quality. Will 3D information display on our target devices? There's lots of 3D viewers out there, but all from different vendors, different ways of integrating them, standalone, perhaps ActiveX, HTML5. There's just so many choices. And the other thing is, does the customer still require hard copy? It might seem a bit kind of going back in the past, but there's still that possibility. And what's the cost to create it? Will it take more time to author the data, and do we have that correct software to create it? So 2D, do we continue down the path of creating and delivering 2D data? Yeah, I think so. I think in the near term, that's still predominantly going to be the format. But in the future, I do see illustrations being delivered in 3D. They might be for specific procedures, that there's a business case to do that, but I do see that happening. So legacy, as I said at the beginning, it's very unlikely these legacy illustrations are going to be updated to 3D. So we need to maintain them and revise them. There's just a vast amount out there. And you just need to think about how you're delivering that data in ATM, or is it hard copy? And I still think there needs to be, to a certain extent, a compelling business case for 3D conversion to go from 2D to 3D. There could be, but it would have to be written and justified. And I think the future is probably a combination of the two. So our main topic today is converting 3D to 2D, and that's where our new product kind of fits in. So the ability to get 3D data has been around for quite a few years now. There's a lot of well-established CAD systems in aerospace and defense and automotive manufacturing. You know, CATIA, Creo, SolidWorks, Inventor, and many others as well. So the data is there. Sometimes the challenge is actually getting it from the engineering department and also getting the most suitable format for repurposing. But it's certainly possible. So what's our target format? Well, in our industry, I still believe CGM, SVG, some kind of vector format, 2D vector format is predominantly what we're trying to get to. And we want that the best possible quality because you still might need to do some revisions to it. You might need to add things to it, hotspots, annotations, and we just need to get them into open formats that we can exchange easily with our customers. So these two formats will still probably be dominant. And as we know, if we're in S1000D, CGM is still the primary format. SVG has grown in significance, mainly for display purposes into items. CAD systems, we have seen some that export in CGM and SVG, but CGM, it tends to be an older version, like version 1, and the quality is very poor. SVG, again, we have seen some CAD systems do it, but again, it's just really not great for format and quality. It's really questionable. And that can cause issues downstream if you're trying to reuse that data. If you want to edit it in any way, the file size and so forth can be problematic. So again, not saying you can't do it, but I would be very wary of some of the systems and what quality of data they're creating. So in 3D CAD, if you're probably aware of these formats, the most common open formats are STEP and IGES. Data rich, and they can provide some really good results when converting 3D to 2D, proven and robust. The other option is native CAD formats. These really probably are optimum, but there's a big reliance and dependency on those proprietary formats being published so third parties can use them. In the CAD world, that does seem to be more common, and certainly something that we've been looking at in our product development so far. On the display side or publishing, so there's two distinct areas here. There's like an export conversion area for file formats, but there's also in 3D a publishing area. And this is one of the things that I'm surprised that S1000D community hasn't really latched onto. We've been looking at a format called X3D, which is based on XML, which is open, structured, seems ideal, and fits really well in with XML, SVG, with CGM as a good open format, rather than having this kind of free-for-all. And that's something we'll probably focus on in the future and discuss at the end of the webinar, what kind of our plans are for that. So there are some guidelines in, certainly, I don't want to labor too much on S1000D, this is my only slide, but there are some guidelines in there for the use of 3D graphics. The production of 3D content must be produced from a verified and authoritative engineering information. So that kind of goes as kind of common sense. And it really applies to both if you're going to deliver this in an item or you're going to use it to convert to 2D. It has to be, the engineering data has to be correct, obviously, and usually is because it's gone through some QA processes. And the software that you do the conversion with or display with has to be able to do that really without a loss of data. Else that could cause tremendous issues, especially, say, in the commercial aircraft industry or defense industry. So, there are some guidelines there. They're very short, very concise. If anybody's taken any notice of them, I'm not quite sure, but you certainly have to have warnings and cautions and things like that. So hopefully people are trying to adhere to these rules that have been set. So technology. So on the 2D side, we provide VXEdit. So I know there's some customers on the webinar today who are using this. So native CGM editing complies to the standards. We've got a really good support of SVG, fully compliant with S1000D, easy to add hotspots both manually and automatically. We have a link to our VisXview HTML5 viewer, which displays CGM without a plugin, or you could view SVG in any popular HTML5 browser. So 2D, we're pretty well covered. We've got a good piece of software that's being widely used. With 3D, we've been kind of lacking, but we've now closed the gap. VisXEdit 3D imports step and IGES, the open file format, converts to CGM directly, and then you can always save as SVG. The 3D model that you'll see in a second, we can quickly and easily manipulate that to require viewpoints. We can explode the 3D model. We can move the parts around. And when we have the required view, we can perform a hidden line removal, and we'll have a 2D CGM illustration. We're calling it VisXEdit 3D, and let's see if we can get it open. So I've kind of opened a model here for expediency. Although in saying that, it takes 23 seconds to open. But 23 seconds in a webinar seems like a long time when you're opening something. So what we've done is we've had like this idea that we wanted to create something more around a viewing environment. So we tried to keep it really simple. And it started off looking really complicated, but we made it really simple. So the interface itself, we have the main window where the model would sit. We have a tree view on the right. So this would be obviously assemblies, sub-assemblies, and so forth. This is a step file. We can open that step file by going to File and Open. We also support IGES as well. So you just select the file that you want to and open it. Just to give you kind of an idea of a benchmark of specs, this is a desktop machine with 12 gigabytes of RAM, and it's an i5 processor, so it's certainly not over-spec'd. So I would expect some of you guys out there have some more powerful machines than this. So it might give you some ideas of benchmarking. Tools. So this is our toolbar. So toolbar, viewing window, and obviously the tree view. So very simple to start using this. Zoom, we can zoom in. I'm using actually the mouse wheel just to zoom in on the model. You'll probably see it's really quick just to move things around. If I go out of the thing, I can easily fit all back in here. If I choose a particular part, I can zoom to fit that selection, so it'll come back in. So really quick to refresh the screen. We've done a lot of work on optimization to really make this as quick as possible to use the model. I can fit that back into the center of the screen. So we also have some other tools here. So if you want to hide parts of this, so sometimes you might bring in the whole model, but you only want to see parts of it. So I could say, I can right click on this and say I want to hide that particular part. On the right hand side, this will be very small, so I don't expect you to be able to see it very well, but you get some feedback on the tree view over here on the right. So it's a cross, so that just shows us that is actually been hidden. When if I show all at the moment, it should come back again. It will change the icon. So I could easily hide parts on here. One of the other things I can do is just click on the part and I can isolate it. So you can see we've got the isolate thing here. So if I'm just using, I want to work with one particular assembly or sub-assembly, I can say isolate, and that just brings this onto its own window. And I can just work with that particular part. And you'll see on the right, virtually everything is now got a cross by it, shows I'm not actually viewing it anymore. So the whole model is still here. I've not got rid of it. It's all still here. It's just hidden. So I can clear the selection. I can show all, so I can get back to where I was before. If the view has changed, I can always go to the initial view and get back to here. Okay, at the moment I'm seeing this as a shaded view, but I could also see it as wireframe. So just to say at this point that we're still in beta, so we're still doing some work on this before the release, the official release. We're hopefully going to work with some beta testers as well. If I click on wireframe, see one of the things here, we want to make this all monochrome. At the moment it's colored, so the bottom part is still there. It's just you can't really see it very well. We still highlight the part as we move over. So there could be times you want to see the wireframe as opposed to the shaded. So we make that possible. So let's go back to shaded. And the other thing is we can do is we've got like a preview mode. So HLR, hidden line removal. This takes a few more seconds just to generate the view. And again, we're going to make this monochrome. So some of the parts are still showing in their colors, but we just want to make this monochrome. And you can still work with this view as well, move it around. You can see the speed that we really work hard on this speed to get the optimization of the speed, even in the HLR mode. So let's just take that off. So hopefully you've seen so far that the way we're working with the model is very straightforward. One of the things we again focused on to make it as easy as possible is the views or preset views. So here we can just kind of rotate this around. Oh, let me just go back to here. So we can move this around kind of that central axis. So that's pretty straightforward to do. But we also wanted an easy way of getting it onto the isometric, because we see that really is the main kind of preset that people want to see. So here we got onto the isometric axis, and then we can just scroll through different angles very quickly. So you can see the refresh is virtually instant. So that's really nice that we can get that view without really trying to manipulate it by freely moving it around or orbiting around. So that's really straightforward. I can zoom in obviously still and zoom out. I can also pan. So instead of actually using the scroll bar on the mouse, this time I hold the mouse down, I can just pan this around to get into the position I want it to be. We also have this advanced view. This is really, we haven't really seen anything like this, but this allows us to rotate around an axis. So we can choose this axis. So if you don't want it on this particular angle, say in this particular x-axis here, then what I can do is I rotate around the z-axis, say 45 degrees, or I could choose a number of degrees. So apply, and then I'm rotating around that axis. So then I can really get the view that I'm looking for. Okay, I'm going to get the this particular area to the top. This is the turbo. And I'm just going to reduce the size. So this is a really nice feature to get that final incremental view that you want. So one thing to bear in mind when the CAD model comes through, invariably it's not in the right view that you want. So you really need to get to that view as quickly as possible. And that's what we tried to do here. Okay, the next thing is explosion. Again, automatic is quite straightforward to implement. And we've got a slider here. So as I slide out, you can see the model explodes. It's quite nice that we can do that, but we don't have a lot of control over the direction that items go into. So that can cause obviously a lot of rework now to reposition these parts. And we don't really see probably an explosion of the whole of the model, of the whole of the engine. There's more likely to going to be sub-assemblies that you can actually explode. So what we can also do is we can manually explode as well. So if I switch this on, if I now click on a part, you'll see we get these arrows. So I'm just going to hold my control key down. When it goes light blue, I can drag this particular part away. So it's very easy just to begin to explode this in the way that I want as the user, as opposed to kind of just automatically doing it. But you could always still go back. You could automatically explode and then move them around individually to get the view that you want. The other option here is that, let me just, I'm going to take the turbo part away. So this is the other thing I like here. I can do it via the tree view, or I can do it via the viewing window. So I want the turbo. Here's all the turbo assembly. And then I can isolate that off. So perhaps this is just the area now that I want to create an exploded view on. It's a sub-assembly. It's more likely to be a technical illustration. So what I can say is manually now, I can begin to drag these parts away. So I'm just going to stop talking for a slight amount of time while I concentrate on this. So let's take these impellers away. And here we go. So I'm just going to take this down to a certain level. And then you could also go, you wouldn't be going vertically in this case, but let's just go up for. And then we can even get down to these kind of levels of parts here. So we've got the shaft and the bolts and so forth. Click on the bolts here, and there's you can shift click, so you could select more than one at a time, and you can do that on the screen. Or we could shift click on the other side on there as well. And you can see perhaps that they're in bold slightly, and then I can move all those together. So really quickly, you could create an exploded view of the turbo unit. Well, hopefully you see that. Let's just fit all. So at this point now, this is where I probably create my 2D illustration. File, export, and we're going to go with CGM. I'm going to go to my desktop. And what we've done here, we've given you two options. We've got export low precision and high precision. Low precision will give you not quite as good a quality file, but it will do it a lot quicker. So it's almost like a preview. So let's just do this one to begin with. We also can choose line width. So I'm just going to choose 0.2 and save. So it's save as opposed to export. It's not really taking any time at all. And it automatically opens into VXEdit. So let's just zoom in on this particular area here. And I think you can see there that the reason this was the low precision. So what we've got here now is a lot of kind of polylines. Still, the illustration will look good when printed, but it just doesn't give us that quality that we might need if we want to change something, or we just need a smaller file size. But we thought it was important to give you like a preview if you just needed it for quality purposes. Somebody just needs to check it that everything's come through and is looking good. Okay, so I'm just going to save that. So I can save that now as a CGM. It could be a web CGM, so we're S1000D compliant. And we can call that, let's call that turbo low. In fact, I'll make that a cap as well in a sec. No, that'll be okay. I'm going to put it on the desktop. We'll just save that way. Okay, so the model is still open, so I can still work with it. I can still export it again. This time I'm going to do high precision. Let's do the same line weight. And what I'll do now is we'll call this predictably high. So again, just doing the export, you can already feel it's a bit longer, but it will get there eventually. 17 seconds. So we give you the export time. I'm not sure we're going to keep that, but anyway, gives you an idea of how long it's taken. Should now automatically open in VXEdit, which it has done, and we'll go to that same area. And you can see now we really have got rid of all those arcs. Now we just have a part of an ellipse. So a much cleaner file. And in theory, it's going to be a smaller file. In this case, it's only a small illustration. Let's just go to the desktop. So the high just takes a few seconds just to, is 121K, and the low is 151. So not a tremendous amount of difference. But if we're looking at bigger files, bigger exploded views, bigger illustrations, and that might compound more. So, but the time-wise, I think is really acceptable to do the conversion. And once we're in VXEdit, obviously we have the benefits of all the tools there. So let's just go back to the high. So now we could do annotations and so forth. So we have the benefits of finishing this off, adding hotspots and so forth to the illustration. Whoops, sorry. So you could annotate the parts, we could hotspot them and so forth. So you really finish off the illustration. We're all in the one same environment, which is obviously a big benefit. Okay, so that's the demo. I think we've pretty much covered everything we've got so far, but I think hopefully you'll see that we have something that's quick, easy to use, and that's one of the things we want to try and show today. It's the speed of which you can create these views and then export them to 2D views without overcomplicating them. The tree view will give you that access to the whole of the model's BOM or structure, including assemblies. You can work with the whole assembly or the whole machine or equipment, or you can break it down and work with those assemblies and sub-assemblies in here very quickly and easily. And if we want to reset, we can reset everything. We can go back to where we were before. We can clear everything. Get back to where we started. So hopefully you like what we've done so far. That's the first time we've actually demoed it, and I think it performed pretty well. So let's go back to the slide. So we're calling it VXEdit 3D. This will be kind of version 1. So we have plans to add more things to it, but we'll keep those kind of under wraps at the moment. We'll share some of them with you today. So the benefits, very easy to reuse that 3D CAD data independent of the engineering department of the CAD system. Support for common open formats, STEP and IGES. Intuitive tools for manipulating the model, getting the required view, isolating assemblies and sub-assemblies, work with those individually, explode the model automatically or manually, convert to industry standard 2D formats such as CGM, and then the quality, we can choose the quality, we can add annotations, hotspots, etc. once we've got that through in the 2D view. So what's next? We are definitely going to have a version 2 of VXEdit 3D, working on some export into other formats as well, like X3D we mentioned, and also VRML, import VRML. We're definitely looking at a 3D spare parts illustration solution because we're kind of already nearly there in the respect of the way that we can bring the model in and begin to work with it. And this would be then the export to X3D. So we're kind of almost there, but not quite. So, and this is now the advantage that we have that base to work from with this 3D technology, that we can now take it in different directions. I mentioned at the beginning viewing. We want to try and create a standard viewing environment for the 3D data we create based around X3D and XML. We don't want to create anything proprietary. We could do, but we don't want to. We want to make it open. And we really want to focus on the X3D format. With X3D, if you want to look into it, you can view 3D files in a web browser with no plugin. So again, gives you there's no overheads with trying to install ActiveX controls and things like that, which could cause internal issues or customer issues. So we have a lot more to plan in the future and think about, but our strategy really is around now expanding on this base that we've created around 3D and trying to remain open and not go into a proprietary world. So we've made certainly significant progress this year supporting 3D, but we're still trying to keep the keywords, adhere to them, conversion, compatibility, and compliance. So that's still our kind of mantra, and we will continue to work with open standards. That's our objective. The roadmap is maturing. Certainly 2D, we're not going to ignore 2D at all. We're going to carry on because that's kind of downstream still important, that all those legacy archive illustrations have to be maintained. And obviously we're always pleased to work with companies who are looking to implement 2D and 3D graphic solutions. Okay, so at this point, if you have some questions, I think Don's going to put his microphone back up and we'll be pleased to try and answer them. Okay, so the first question, if you have a large equipment, can move into equipment to see the interior components? Well, yes, you can, because we can hide components or hide the main body, and then we can really look into what's below. And that's where wireframe comes in as well, because you could see through down to other component levels. So the answer is yes. You've also got the tree view as well, which allows you to kind of isolate those out. So you could really bring out any part of the equipment and begin working with that. At the beginning, so the question is, what file formats can you start from? Only STEP and IGES. Correct. We are only supporting STEP and IGES, but we're already looking at other formats. So that will be coming after the release of the initial software. We'll be looking at other kind of proprietary formats, but also other open formats. So Don, do you want to comment on the file formats? You've been looking into that a bit more deep, in depth.
Yeah, well, we're looking at which, of course, native CAD converters. I mean, there's some other open formats like we would want to support, like Vermal, VRML, but of course, Vermal are not true models. They're just a graphical representation. So native CAD formats, you know, the big ones, of course, are CATIA, SolidWorks, Creo, Siemens NX. So we're looking at those, I think, initially. And we would like to, you know, hear from you guys too. What if you have the ones that you are having to deal with now? We'd like to hear from you too, and hopefully use that as direction for development. So so yeah, it'll be the native CAD formats, like I say, the big 3 or 4: CATIA, SolidWorks, Creo, and NX, and then perhaps the Autodesk Inventor.
Thanks, Don. Another question again. We did think we'd get a lot of questions around file formats. So, what file format is VisX 3D file saved in?
Well, okay, excuse me.
Yeah, go ahead. You go ahead, Don.
Yeah, well, currently it exports. If you want a vector image, it's a 2D CGM file. And then you can also get an image format too, like a PNG or JPEG. But now for future, I think perhaps the attendee is asking more about 3D formats. And I think for the future, we're looking to X3 3D because it's an open XML format. So I think would be the export formats that we're currently to have and then are looking at for future.
Yeah, so I just brought up then the one thing I missed was we can save as image formats as well. So just in case you need a quick view of the shaded view, then we can always do that. Sorry, I missed that out. Yeah, if you're alluding to, do we have our own 3D format? Then no, we don't. So we reopen the step file or the IGES file. So there isn't a way currently that we can save in a native kind of 3D format that we'd still have to open the IGES or the step file to work with the model again. So, but as Don mentioned, what we do envisage is we'd probably, rather than native format, we would create an open format, such as X3D, to work with. So that is more of the strategy than to create a native format. Although we have looked at that, at the moment we haven't implemented it. So that there is a native format to the software that we've created, but we feel at the moment you can just reopen the IGES and step files very quickly. But if again, as we get more feedback from users, from beta testers, whatever, then we will look to implement like something in version 2, perhaps. Yeah, so that was one of the main things that we obviously have to consider is where the data is coming from, you know, and what access as the user or illustrator or author got data they got access to. You know, what they don't want to do is actually go to a CAD department and ask for some specific format when they don't create it, because obviously that immediately creates a hurdle that the perhaps engineering don't want to cross. So pretty much they'll always save as native. So that is the kind of lowest common denominator. So it's something we're already looking at, but it won't be in version 1. Okay. So another question here, can you manually move an exploded object by inputting a distance? No, not at the moment, but it's a good suggestion. So that's something we could look to implement. Obviously, it depends on scales and so forth of knowing what the scale of the model is. But I think that's something we can look at, Don. Say choose an object and say I want to explode it so many a certain distance down the z-axis.
Right. Yeah, that's a good suggestion. Yeah, that would be fairly easy to do. Right now, we have that slider right now that's just kind of a variable distance control, but it would be interesting to actually maybe have a little box to input that manually. So yeah, good suggestion.
Yeah, so this is kind of what we're looking for as well, is that we'll be looking for feedback from people. We think this does a good job now, but we think obviously it's version 1, but it's already, to me, very usable. So version 2 obviously is going to be an improvement. The thing is with proprietary formats, then they're available and we can integrate them straightforward. The integration is just really knowing what people want. We don't want to integrate something that nobody needs. So, but we do obviously look at things like CATIA, Creo, and things like that will probably be the top of the list. Okay. So can you choose one specific subassembly to explode and leave the other assemblies alone? Yeah, you could. You can do that. So you'd leave the main model in situ. It depends what the layout of that is going to look like in the end, but definitely possible to do that. I isolated it, but in theory, you could choose the turbo and explode it. But obviously, the thing is that the model, if it's covered, if the viewpoint is not correct, then exploding the turbo could actually, you won't be able to see it very well. You'll see the model behind it as well. So you can have like an overlap. So you can definitely do it. How you would do it, you might want to put it in a bubble or something like that to the side to do the explosion and have like the main model as the kind of the glass helicopter type thing. So definitely possible. It just depends how you would want to implement it. Good questions, by the way. And obviously, we want to give the some of our kind of users the opportunity to beta test this as well. So, and that will probably be the next stage. Okay, I think that's the end of the slides, and perhaps I'm going to say the end of the questions, but not quite. Can you add custom line width options to the 2D CGM export? If you're driving it, can we do thick and thin? No, not currently. But you certainly can vary the line weight or the base line weight of the illustration. You might have seen from the drop down that we can, when we go to file and export, that we can choose the line weight, but it's going to be a single line weight. If you're looking for thick and thin, it's not something we're doing automatically at the moment. But in saying that, once it's through into VXEdit, you can obviously apply line widths in there to select the line. You can create, if you've got thick and thin, you could create it in there quite quickly as well. So we still see the finish. That's why we wanted this link to VXEdit, that we still believe you're going to have to finish the illustration off by adding hotspots or annotations or changing some line weights. So you've still got that connection between the two. Okay, can a different option be added to the drop down, e.g., mate? Oh, I see. 1.3 millimeter. Yeah, it could be. I believe that, Don. We could have changed the. You might have perhaps a custom line weight in there rather than just a fixed one.
Yeah, that's another good suggestion, a good refinement to it.
Yeah.
Sure.
The other thing is, once it's come through, you could just do a select all and then change it to your line weight that you've set up in VXEdit. So that's the other other thing that you can do. So either way, you could do it very quickly. So thank you for all the questions. A lot more than we thought there would be. But that's always great to get feedback. I'm really pleased that you could join us today. I usually have a closing remarks, but we don't have one today. And that's mainly because the world we're in at the moment, we haven't really planned what our next event will be. But we certainly want to approach some of our customers to get them into beta on this. Am I correct in thinking, Don, we haven't got an official release date yet, but it is kind of imminent. Is that correct?
Yes, within the next week or two.
Okay. So yeah, we're going to approach some beta, but then within the next 2 weeks, we'll be sending out pricing and availability. So you should be able to get a hold of this pretty soon. So just like to thank everybody for attending today. Please remember you will get an email with a link to the recording. So you can always pass that on to your colleagues or watch again if you want to. We'll be sending out some marketing materials in the future as well. So, but you've seen the main functionality today. We hope you like it. Please send us some feedback to our email, to website. There'll be an eval version as well, so you'll be able to try it out before you buy. And one other thing that what we've been thinking about doing is we have the VXEdit Plus version of VXEdit. What we're thinking of doing is actually implementing a 3D viewer inside that product. So it won't have all the functionality you've seen today, but it will be a 3D viewer that you can call on to look at models within VXEdit. So kind of a stepping stone to doing the full version, but that's another thing we're seriously thinking of doing. So really bringing the 3D world into 2D with VXEdit. So thanks for everybody attending. It's been a pleasure to do the demo today, and we look forward to speaking to you again soon. Have a great day.